Steelmaking is the process for producing steel from iron ore and scrap. In steelmaking, impurities such as nitrogen, silicon, phosphorus, sulfur and excess carbon are removed from the raw iron, and alloying elements such as manganese, nickel, chromium and vanadium are added to produce different grades of steel. Limiting dissolved gases such as nitrogen and oxygen, and entrained impurities in the steel is also important to ensure the quality of the products cast from the liquid steel. Steelmaking has existed for millennia, but it was not commercialized until the 19th century. The ancient craft process of steelmaking was the crucible process. In the 1850s and 1860s, the Bessemer process and the Siemens-Martin process turned steelmaking into a heavy industry. Today there are two major commercial processes for making steel, namely basic oxygen steelmaking, which has liquid pig iron from the blast furnace and scrap steel as the main feed materials, and electric arc furnace steelmaking, which uses scrap steel or direct reduced iron as the main feed materials. Oxygen steelmaking is fueled predominantly by the exothermic nature of the reactions inside the vessel, whereas in EAF steelmaking, electrical energy is used to melt the solid scrap and/or dry materials. In recent times, EAF steelmaking technology has evolved closer to oxygen steelmaking as more chemical energy is introduced into the process. History. Steelmaking has played a crucial role in the development of modern technological societies. Cast iron is a hard, brittle material that is difficult to work, whereas steel is malleable, relatively easily formed and a versatile material. For much of human history, steel has only been made in small quantities. Since the invention of the Bessemer process in the 19th century and subsequent technological developments in injection technology in process control, mass production of steel has become an integral part of the world's economy and a key indicator of technological development. The earliest means of producing steel was in a bloomery. Early modern methods of producing steel were often labor-intensive and highly skilled arts. See finery forge, in which the German finery process could be managed to produce steel. Blister steel and crucible steel. An important aspect of the Industrial Revolution was the development of large-scale methods of producing forgeable metal. The pudding furnace was initially a means of producing wrought iron, but was later applied to steel production. The real revolution in steelmaking only began at the end of the 1850s, when the Bessemer process became the first successful method of steelmaking in quantity, followed by the open hearth furnace. Modern processes. Modern steelmaking processes can be broken into two categories: primary and secondary steelmaking. Primary steelmaking involves converting liquid iron from a blast furnace and steel scrap into steel via basic oxygen steelmaking or melting scrap steel and/or direct reduced iron in an electric arc furnace. Secondary steelmaking involves refining of the crude steel before casting, and the various operations are normally carried out in ladles. In secondary metallurgy, alloying agents are added, dissolved gases in the steel are lowered, and inclusions are removed or altered chemically to ensure that high-quality steel is produced after casting. Primary steelmaking. Basic oxygen steelmaking is a method of primary steelmaking in which carbon-rich molten pig iron is made into steel. Blowing oxygen through molten pig iron lowers the carbon content of the alloy and changes it into steel. The process is known as basic due to the chemical nature of the refractories calcium oxide and magnesium oxide that line the vessel to withstand the high temperature and corrosive nature of the molten metal and slag in the vessel. The slag chemistry of the process is also controlled to ensure that impurities such as silicon and phosphorus are removed from the metal. The process was developed in 1948 by Robert Ehrer and commercialized in 1952-53 by Austrian VOESD and AMG. The LD converter, named after the Austrian towns of Linz and Donawitz, is a refined version of the Bessemer converter where blowing of air is replaced with blowing oxygen. It reduced capital cost of the plant's time of smelting, and increased labor productivity. Between 1920 and 2000, labor requirements in the industry decreased by a factor of 1,000, from more than 3 worker hours per ton to just 0.003. The vast majority of steel manufactured in the world is produced using the basic oxygen furnace. In 2011, it accounted for 70% of global steel output. Modern furnaces will take a charge of iron of up to 350 tons and convert it into steel in less than 40 minutes, compared to 10 to 12 hours in an open hearth furnace. Electric arc furnace steel making is the manufacture of steel from scrap, a direct reduced iron melted by electric arcs. In an electric arc furnace, a batch of steel may be started by loading scrap, a direct reduced iron, into the furnace, sometimes with a hot eel. Gas burners may be used to assist with the meltdown of the scrap pile in the furnace. As in basic oxygen steel making, fluxes are also added to protect the lining of the vessel and help improve the removal of impurities. Electric arc furnace steel making typically uses furnaces of capacity around 100 tons that produce steel every 40 to 50 minutes for further processing. Byproduct gases from the steel-making process can be used to generate electricity through the use of reciprocating gas engines. Secondary steel-making. Secondary steel-making is most commonly performed in ladles and often referred to as ladle. Some of the operations performed in ladles include deoxidation, vacuum degassing, alloy addition, inclusion removal, inclusion chemistry modification, desulfurization and homogenization. It is now common to perform ladle metallurgical operations in gas-stirred ladles with electric arc heating in the lid of the furnace. Tight control of ladle metallurgy is associated with producing high grades of steel in which the tolerances in chemistry and consistency are narrow. Jschnalzer steel making. The Jschnalzer steel making process is a process for primary steel making in which iron ore is processed almost directly into steel. The process is based around a new type of blast furnace called a cyclone converter furnace, which makes it possible to skip the process of manufacturing pig iron pellets that is necessarily for the basic oxygen steel making process. Without the necessity for this preparatory step, the Jschnalzer process is more energy efficient and has a lower carbon footprint than traditional steel making processes.